Hello, I am Dr. N.S. Mani. In this video presentation, which is a series of videos, I am going to deal about basic principles of ECG analysis. You can use the pause button and play button to control the speed of the video streaming if the video is being played very fast, so that you can follow the visuals. When you get a ECG recording, there are mainly 12 points which you have to look for. Make sure that you are dealing with the right ECG record, which means identify the patient name, the ID number, the age, sex, the date on which the ECG was recorded, and the time at which it was recorded. These are very important in the initial stage itself, otherwise you will be wrongly interpreting. And if possible, please note down the main clinical features also, so that you have some idea of what clinical condition you are looking for. The preliminary steps which we will look for are the ECG grid, secondly the complexes and the intervals, the P wave, the PR interval, QRS complex, ST segment, T wave, QT interval, U wave. Then calculate the heart rate and axis and analyze the rhythm if there is any abnormality. So in the systematic approach in the ECG interpretation, the important steps are: one is to locate the P wave, then establish the relationship between P wave and the QRS complex, then analyze the QRS morphology, then search for any other clues and interpret the rhythm in the clinical setting. Now let us go to the details. Grid lines and standardization of the ECG. The figure shows the calibration signal, how the strip is divided into 0.2 second, which again is further divided into 0.04 second. Then vertically how the grid is divided into 10 millimeter, that is 1 millivolt. The electrocardiogram is recorded on a paper that has large boxes, that is heavy lines of 0.5 centimeter sides, that is 5 millimeter. On the horizontal axis, each large box, which represents 0.2 seconds at a typical paper speed of 25 millimeter per second, it is divided into 5 smaller boxes, each one representing 0.04 seconds. On the vertical axis, a large box also has 5 subdivisions, each 1 millimeter in height, that is 10 millimeter equals 1 millivolt with standard calibration. Now the ECG complexes and intervals. ECG waves are labeled alphabetically, starting with the P wave, followed by the QRS complex and the STT complex, that is ST segment and T wave. The J point is the junction between the end of the QRS and the beginning of the ST segment. The PR interval is measured from the beginning of the P wave to the first part of the QRS complex. The QT interval consists of the QRS complex, which represents only a brief part of the interval, and the ST segment and the T wave, which are of longer duration. The formation of the major deflections on the ECG is shown in the picture. Yes, you are seeing the figure of heart on the left upper panel. The SA node is shown, which is in blue color. The intra-atrial pathways are shown as the green lines. The left atrium is shown on your right side, right atrium on your left side. The yellow round thing in the middle at the level of the AV value is the AV node. Then below is the His bundle, which divides into two, the Purkinje fibers, and they are numbered as 1 to 7, and correspondingly you can see the wave which are represented on your right side in the same panel. So please follow the number and the wave so that you will understand which wave is created and its anatomical relationship. One is the SA node discharge, which produces no deflection. The number 2 is right and left atrial activation, which is the P wave. Number 3 is the activation of AV node and the bundle of His, which produces no deflection. Then number 4A and B are there. 4A is septal activation, which is the onset of QRS complex, and that produces initial septal Q wave. 4B is the left ventricular free wall activation, which is the inscription of the QRS complex. Then number 5 is full ventricular activation, which produces no deflection. Number 6 is ventricular repolarization, which is the His-Purkinje T wave, and the late ventricular repolarization, that is His-Purkinje U wave. The electrical impulse is initiated in the sinus node, then activates the right and left atria, generates the P wave. Impulse conduction through the atrioventricular node, AV node and bundle of His, which are small structures, does not generate any electrical activity, no ECG activity. This period of electrical silence is the PR interval. The first part of the ventricle to be depolarized is the left side of the interventricular septum, producing a small septal Q wave, followed by depolarization of the remainder of the ventricular myocardium, generating the full QRS complex. The T wave represents ventricular repolarization. A U wave may be present, representing repolarization in the His-Purkinje system. Now, how can you calculate the frontal plane axis? The lead 1 and AVF are taken as two main leads, which divides the quadrant or the square into 4 parts. On your right side is the lead 1 0 degree, and on your left side the horizontal is the minus 180 degree or the plus 180 degree. The whole circle is 360 degree. The lower segment is plus 180 degree, and the upper half is the minus 180 degree. Or you can go in the clockwise direction and say 0 to 360 degree. And the plus 90 degree is the lead AVF positive, and minus 90 degree is the north pole, that is a negative part of the AVF. And the normal axis is in the right lower quadrant. Lead 1 will be positive and AVF will be positive. And the lead 1 negative and AVF is positive. This means it is in the right axis, which is the 4th quadrant. If the lead 1 is positive and AVF is negative, it is in the quadrant 2, that is left axis deviation. If the lead 1 is negative, AVF is negative, it is indeterminate axis, that is a quadrant 3. So place your left thumb on lead 1, right thumb on AVF, that is a thumb rule. Which thumb shows more positive wave, that is the axis. That is easy way at bedside. Lead 1 and AVF divide the frontal plane into 4 quadrants. If the QRS complex is positive, that is upright in both leads, then the axis falls within the quadrant 1, that is normal. The QRS complex is positive in lead 1 but negative in AVF, then the axis falls within quadrant 2 and is leftward, that is the left thumb. If the complexes are negative in lead 1 and positive in AVF, that is right thumb, then the axis is in quadrant 4 and is right axis. If the complexes are negative in both leads, then the axis is in the quadrant 3 or indeterminate. That is both thumb shows negative deflection. There are certain conditions which have to be thought of when you notice some abnormality in the ECG recording. P wave before each QRS complex with constant PR relationship. If the QRS is regular, note the atrial P wave rate. It can be less than 100 or 100 to 220, or it can be 220 to 260 or 260 to 320. If it is less than 100, P wave morphology is normal, means normal sinus rhythm. If the P wave morphology is inverted, heart rate less than 100, it is ectopic atrial rhythm. Heart rate between 100 and 220 and the PR interval is less than 0.2 seconds, that is not prolonged. It may be sinus tachycardia, sinus node re-entry, atrial tachycardia, atypical AV node re-entrant tachycardia, that is long RP, then AV re-entrant tachycardia, accessory pathway. 100 to 220 heart rate with the PR interval long, that is more than 0.2 second. It can be sinus tachycardia with the first degree AV block, atrial tachycardia, atypical AV nodal re-entrant tachycardia, AV re-entrant tachycardia, accessory pathway. In both these conditions, if the P wave is normal, then think about sinus tachycardia and sinus node re-entry. In both these conditions, that is heart rate P wave between 100 and 220 and PR interval either less than 0.2 or more than 0.2. Abnormal or inverted P wave, you think about atrial tachycardia, atypical AV node re-entrant tachycardia, that is long RP, or AV re-entrant tachycardia, accessory pathway. Don't worry, all this will be shown as with the models. I am only telling the initial clinical conditions right now. Now the third possibility is that atrial P wave rate is 220 to 260. It's either atrial flutter or atrial tachycardia. Look for the P wave. If it is distinct, it is atrial tachycardia. If the P wave is undulating, negative or positive, it is atrial flutter. If the P wave heart rate is 260 to 320, it is atrial flutter. The remaining part of the video presentation can be seen in the next video, that is number 2. Thank you for this viewing. Please visit the channel every day, www.youtube.com/ACEPGMAT. If you got Facebook account, please make friends with facebook.com/ACEPGMAT. After inviting us friend, click like.